In this video, I'm going to walk you through how to get your first program running. Let's have a look. What we need to do is we need to start by getting a terminal session going. Now, obviously, if you are on a Linux machine, this will look a little bit different than it does on my Mac. You may have to look into how to get it going on a different operating system yourself. So let's have a look here. So I actually have terminal in my application bar down here, but let me show you where to find it. It's under Utilities, Applications, Utilities, and then you see terminal here, and what you're going to want to do is drag that onto your application bar, but since it's there already for me, I'm just going to leave it alone, and I'll just get it started by double clicking on that. So now we have what's known as a terminal session going. Now, presumably somewhere you created a directory LAFF-On-Programming for High Performance. I happen to have that in my Dropbox, and therefore that's where I'm going to go. Probably not the best place to keep it, but it's a place. Now within that directory you have a subdirectory called Assignments. That's how you set it up in week 0. So let's go to that. And then within that you have a subdirectory called week 1, and within that you have a subdirectory called C, and in that C directory there'll be a bunch of stuff there, and what all is there, let's walk through that in a separate video. For now, what I want you to do is have the experience of executing the simple triple nested loop that is in the file called gemijp.c. And if you look at that file, you see something like this. All right, so that's a simple triple nested loop as we described in this unit. Now, to execute this, we use something called a makefile. And for now, all you need to know is that in order to execute it, which means compiling it, linking it, and then executing it with certain data, all you have to do is say make IJP. And notice that it's showing me that it's compiling. Then it's showing that it linked it, and now it's piping some, let's see, right here, it piped, that's what they call it in Linux, some input into the program that was created called driver ijp.x. The // means look for that program in the current directory, and the output is then redirected into a file called data/output ijp, and then for good measure the command that's executed when you say make IJP also shows you the exact data that was generated along the way. And some of the things that are important to look for here is the last line here, maximum difference between the reference and your implementation. And this here says that it's roughly 3.2 times 10 to the minus 13th, which is close enough for practical purposes. Notice that when you execute a matrix multiply with double precision numbers, which is how real values are stored, then inherently when you execute it you will incur some round-off error along the way, and therefore the exact order of the loops in the matrix multiply can yield a slightly different result, again due to this round-off error. So that's what we want to look at. Just for good measure, there's a reference implementation, and then there's your current implementation that for which we are going to report timing and performance numbers. What I want you to do is ignore the reference implementation numbers altogether for the moment. Just don't even look at those. And for the current implementation, you see a column that says what the execution time was, what the gigaflops attained are, and we'll talk about that in a minute, and then what the difference is between the result computed by the reference implementation and the current implementation. So try to get to this point, and then in the next video we'll talk about how to visualize the data that comes out of this.